Let us solve some problem on AC, and these are the formulae required. The first one is Vrms is equal to V0 divided by root 2, where V0 is a peak value of voltage and omega is angular frequency, that is 2 pi divided by T, that is equal to 2 pi f, where T is the time period of AC and f is the frequency of AC, and T and f are related by this formula, and XL is inductive reactance, that is XL is equal to omega into L, that is equal to 2 pi f into L, and X is equal to capacitive reactance, that is equal to 1 divided by omega C, that is equal to 1 divided by 2 pi f into C, and impedance in a circuit, series LCR circuit, that is equal to square root of R square plus XL minus XC whole square, and impedance can also be found by Z is equal to Vrms divided by Irms, and tan phi is equal to VL minus VC divided by VR, where phi is the phase difference between voltage and current in a series LCR circuit, and that is equal to XL minus XC divided by R, and this is also a formula to calculate tan phi, and F naught, that is a resonant frequency in series LCR circuit, that is equal to 1 divided by 2 pi root LC, where L is the value of inductance and C is the value of capacitance. And quality factor in a series LCR circuit is given by these formula. It is given 4 and 5th one here. So VL by VR, that is equal to VC divided by VR, that is equal to omega naught L divided by R, that is equal to 1 divided by omega naught CR, where VL is voltage across the inductor and VC is the voltage across capacitor and VR is the voltage across the resistor, and omega naught is angular resonant frequency and that value is 1 divided by root LC. And next, one more quality factor formula, that is equal to F0 divided by F2 minus F1, where F2 minus F1 is a bandwidth, and one more last formula, that is power factor cos phi is equal to R divided by Z. R is the resistance in a circuit and Z is impedance in a circuit. To remember these formulae, you need to have a triangle, and this triangle is called as impedance triangle. Along hypotenuse side, if you take Z, and on adjacent side you need to take R, and opposite side you need to take XL minus XC, and this angle is phi. If you use a Pythagoras theorem for this triangle, you will get the value of Z, and if you take cos phi, you need to get the value of power factor, and if you want to get tan phi, that is equal to XL minus XC divided by R, that also can be found by using this impedance triangle. And let us solve these problems. The first one, a 220 volt AC voltage source is connected across a pure inductor of inductance 0.5 Henry. So first let us draw a circuit for better understanding. So this is a pure inductive circuit, that is inductor is connected to AC source, and this is 0.5 Henry they have given, and the value of voltage, that voltage is actually the Vrms, that is equal to 220 volt. Find the current through the inductor. What is the value of current through the inductor, and that current is actually Irms. What is the value of Irms? That's what they are asking it. If the frequency of source is given, in the first case it is 100 Hertz, and in the second case the value of F is equal to 150 kilohertz. And what is the power lost in the inductor? What is the power lost in the inductor? That's what they're asking it. So the first one, to calculate the value of current, that current formula is Irms is equal to Vrms divided by XL. How we got this relation? We got this relation by using a basic formula of Irms, that is equal to Vrms divided by Z. But what is the value of Z? The value of Z is equal to square root of R square plus XL minus XC whole square. But since in a circuit there is no R, therefore R is equal to 0 and there is no capacitor, so XC value is 0, then you will get Irms is equal to Vrms divided by XL. And XL value we can calculate it by using XL formula, that is equal to 2 pi f into L. L value given, F value is also given in case A. So to solve the case A, for case A, Irms is equal to Vrms, that is 220 volt divided by 2. The value of pi you can substitute into F value is 100 Hertz they have given it, and the value of L is equal to 0.5. So if you calculate it, the value of Irms is found to be 0.7 amps. And in second case they have given the value of frequency of AC is 150 kilohertz. So instead of F you can substitute, instead of 100 Hertz you can substitute here 150 kilohertz. So I will do that. So that is B is equal to Irms 220 divided by 2 pi F. F value is, now it is 150 kilo. Kilo means 10 to the power 3 into 0.5. If you substitute all the values and calculate it, the value found to be 0.46 milliamps. And coming to the third one, what is the power? The power lost in inductive AC circuit. We studied that in the theory itself, the current flowing through the capacitor, inductor without any power loss, and that is wattless current. Therefore, power in an inductive circuit is equal to 0. So about this we studied in the theory itself. And next one, if a coil is to have a reactance of 16 ohm for a frequency 2 kilohertz, they have given a coil. The coil is nothing but inductance coil. The coil is having a reactance, that is XL is equal to 16 ohm. For a frequency of AC, if you connect it AC of 2 kilohertz, the reactance is XL is equal to 16 ohm. They have given it. Then what must be its inductance value? And later, what will be the reactance at the value of frequency is equal to 10 Hertz. Okay. So first, what they have given it, the value of F they have given, and the value of XL also given. So first we need to calculate what is the value of L. So we have a relation between XL and L is XL is equal to 2 pi F into L. Then L is equal to XL divided by 2 pi F, that is equal to XL value, that is 16 divided by 2 pi, and the value of F here it is 2 kilohertz, 2 into 10 to the power 3 hertz. If you calculate it, and the value found to be 1.27 millihenry. So this is the value of L we got. Now the second case, what is the value of XL? What is the value of XL when the frequency of AC is changed to 10 Hertz? That is equal to the value of XL. The formula is 2 pi F into L, and here F value is 10. So that is equal to 2 pi value into F, that is 10, into the value of L we found it just now, that is 1.27 millihenry. So the value we found to be 0.0791 ohm. XL is equal to, it is 7.9 into 10 to the power minus 3 ohm, or you can write it as 7.91 into 10 to into or milli ohm. So this is the value of XL found it at 10 Hertz. Okay, the next question is, a coil having an inductance of 2 Henry and a resistance 10 ohm is connected to 220 volt 50 Hertz AC supply. That means a coil is connected to a resistor, and both of them is connected to AC source of frequency F is equal to 50 Hertz, and the value of voltage is Vrms, that is 220 volt. And the value of L is given, that is 2 Henry, and the value of R is given, that is equal to 10 ohm. First one, they are asking what is the value of impedance in a circuit, and second they are asking what is the value of current, that current is Irms, and next they are asking the third one, that is what is the value of power factor cos phi, and next they are asking fourth one, what is the phase difference between voltage and current. So we'll start solving the problem. The first one, we need to calculate what is the value of Z. We have Z is equal to square root of R square plus XL minus XC whole square. Since there is no capacitor connected in a circuit, therefore XC value is equal to 0. Therefore Z is equal to square root of R value, that is 10 square, plus XL value. We need to substitute that, but we don't have XL value directly, but we know the formula of XL, that is 2 pi F into L. So we'll substitute that, 2 pi F into L, it is squared. So the value comes out to be, first we will substitute those values. Ten square plus 2 into 3.142 into F value, that is 50, into L value they have given 2. square it, and if you calculate the value of Z, it comes out to be 628.07 ohm, and this is the value of Z. So we found the value of Z now. Next, we will calculate what is the value of current. What is the value of current? The formula for current is Irms. This is the second one. Irms is equal to Vrms divided by Z. That is equal to Vrms value is 220 volts. They have given in a question itself. And Z value we just found it, that is 628.07. And if you calculate it, the value comes out to be 0.35 amps. And next, third one, what is the value of cos phi? That is power factor. Third one, power factor cos phi is equal to R divided by Z. The value of R given in a question, that is 10 ohm, and Z value we found it. So we will substitute that. Z value is 628.07 is equal to, the value comes out to be 0.015, and this is the value of power factor. And the next one, fourth one, they are asking what is a phase difference. To calculate the phase difference, phi, we just found what is the value of cos phi. The cos phi is equal to 0.015. Then phi is equal to cos inverse 0.015. If you calculate it, you can use the Clark's table, or just by inspection you just see the cos inverse, the value is almost 0. So cos inverse 0 is almost equal to 90 degree. So the value is supposed to be near to 90 degree. Or you can calculate using Clark's table. The value comes out to be 89.5 degrees. And this is the value of phi. And next question. A resistor, an inductor and a capacitor are connected in series with 120 volt 100 Hertz AC source. So they have given here a resistor, an inductor and capacitor. All these are connected in series with an AC source of 120 volt. So Vrms value 120 volt and F value given, that is equal to 100 Hertz. Voltage leads the current by 35 degree in a circuit. They have given voltage leads the current. So voltage leads the current in an inductive circuit, that is inductive predominated circuit. So XL is greater than XC, it is understood. And they have given if the resistance of the resistor is 10 ohm, the value of R is given 10 ohm, and the sum of the inductive and capacitive reactance. Sum of the inductive and capacitive reactance, that is equal to 17 ohm. Calculate the self-inductance. Self-inductance of the inductor, that is L. We need to calculate value of L. Okay, now To calculate L, we have a formula that is equal to XL is equal to 2 pi F into L. F value we know it, XL value we don't know. So we have to calculate what is the value of XL. But XL value they have not given, but they have given XL plus XC is equal to 17. But XC value also we don't know. So how to calculate it? But they have given here the value of 5. Voltage leads the current and phi value is given 35 degree. So we can solve this problem by first step I'm using tan phi is equal to XL minus XC divided by R. Calculate XL minus XC from this equation and we have XL plus XC is already given and solve those two equations and you will get the value of XL. So XL minus XC from this equation we will get XL minus XC is equal to R tan phi. So XL minus XC is equal to R. R value is given, I will substitute that. R value is equal to 10 ohm tan 35 degree. You can able to find the value of tan 35 using a Clark's table and you will get the value of tan 35 degree is 0.7002. So if you multiply 10 you will get 7.002 or this value I will write it as close to 7 ohm. So this is the value of XL minus XC. Okay, we got XL minus XC and we already know what is the value of XL plus XC. So XL plus XC is here. XL plus XC also we know it, that is equation 1, and XL minus XC also we know it, that is equation 2, and solve these two equations. Solving 1 and 2. So the equation 1 is XL plus XC is equal to 17. XL plus XC is equal to 17 ohm and XL minus XC is equal to 7 ohm. If you solve these two equations, you can add these two equations, then you will get 2 times XL is equal to 24. Then XL is equal to 12. So 12 ohm you will get. So once if you got XL value, you can easily calculate what is the value of L by applying the formula XL is equal to 2 pi F into L. Therefore, L is equal to XL divided by 2 pi F. So XL value we found it, that is 12 divided by 2 into 3.142 into F value. They have given 100 Hertz in a problem. See 100 Hertz. Therefore, the value comes out to be 0.019 Henry or 19 millihenry. So this is the value of self-inductance of the inductor. A 100 ohm resistor is connected to 220 volt 50 Hertz AC supply. What is the RMS value of the current in the circuit? And what is a net power consumed over a full cycle? So here they have given only a resistor connected to AC source. So the resistor value is 100 ohm, is connected to AC source of 220 volt, that is VRMS, and the value of frequency of AC source is 50 Hertz. What is the value of RMS value of current? That is the first one. And B, what is the net power consumed? What is the net power? That is PRMS consumed over a full cycle. Over a full cycle means you need to calculate RMS value. So IRMS, we have IRMS is equal to VRMS divided by R. And if you substitute the value of VRMS, that is 220 volt divided by the value of R is 100 ohm, and the value comes out to be 2.2 amps. This is the value of IRMS. And power PRMS, that is equal to IRMS square into R. This is a power formula we are going to use, and this is equal to 2.2 square into 100, because R value is 100 and the value comes out to be 484 watt. So this is the value of power consumed over a full cycle of AC. So it should be RMS value of power. That is why the current is also RMS value we took. Okay, next question. A series LCR circuit is connected to 220 volt AC source of variable frequency. The inductance of the coil is 5 Henry. So try to draw the diagram, and capacitance of capacitor is given 5 microfarad and resistance of 40 ohm. So they have given here a series LCR circuit. It consisting of L, and it have capacitor, and it connected to a resistor also. And this is connected to an AC source of 220 volt and 220 volt, but frequency is variable. The value of VRMS is 220 volt and the value of L is 5 Henry, and capacitance of a capacitor is 5 microfarad and the resistance value is 40 ohm. Calculate the resonant frequency. What is the value of F0? Resonant frequency, that is the first one. And second one, they are asking here, what is the current in the resonant circuit? Current. And later they are asking what is the value of inductive reactance, that is XL value. So first we have to calculate what is the value of F0. We have F0 is equal to 1 divided by 2 pi root LC. So substitute the value of constants and values given. 2 into 3.142, root L value, that is 5, and C value 5 into 10 to the power micro means 10 to the power minus 6. So power is even itself, no need to change the power. That is equal to, if you solve this, you will get the value of F naught, that is equal to 0.031 into 10 to the power 3 Hertz, or it is equal to 31 Hertz. So this is the value of resonant frequency, that is 31 Hertz. And next they are asking here what is the value of current, that is a resonating current, the current at resonance, that is Irms is equal to Vrms divided by Z. But Z value we can substitute it, that is square root of R square plus XL minus XC whole square. But at resonance, they are asking resonant current, therefore at resonance, XL should be equal to XC. So if you substitute those values, you will get Irms is equal to Vrms divided by R. So directly we can take this formula instead of doing all these steps. At resonance, Irms is equal to Vrms divided by R. So the value, if you substitute, Vrms is equal to 220 volt divided by R value that is given, that is 40 ohm. The value, if you calculate, it comes out to be 5.5 milliamps. Sorry, it is 5.5 ampere itself. Next they are asking third one, that is C XL value. XL is equal to 2 pi F into L. So substitute the values. F value, here it is F naught, because at resonance XL value and XC value both are equal, but F naught value we found it, that is 31 into the value of L, that is equal to 5. So if you calculate it, the value comes out to be 0.973 into 10 to the power 3 ohm, or 973 ohm, and this is the value of XL. So next question we will see. A 60 microfarad capacitor is connected to 110 volt 60 Hz AC supply. Determine the RMS value of the current in the circuit. So what they have given, a 60 microfarad capacitor is connected to 110 volt AC supply. So this is AC supply of 110 volts and 60 Hertz. So Vrms is given, Vrms and the frequency of AC. Determine the RMS value. So what is the value of RMS value of current? So RMS value of current is given by Irms is equal to Vrms divided by Z. but the value of z, formula of z is square root of r square plus xl minus xc whole square. Here there is no inductor in a circuit and there is no resistor in a circuit, so both the values are 0. Only xc will left as it is, therefore Vrms divided by xc. So this is the formula of Irms. So Vrms is given and xc we need to calculate. The value of xc, the formula of xc we can write, that is xc is equal to 1 divided by 2 pi f into c. So f value is given, c value is also given. The value of c given here in a question is 60 microfarad. So c is equal to 60. Micro means 10 to the power minus 6 farad. So we'll substitute both the values in the equation. Therefore 1 divided by 2, pi value is 3.142, f value that is 60 Hertz into c value that is 60 into 10 to the power minus 6. So if you solve this, the value of xc comes out to be 53.04 ohm. And now we can able to calculate what is the value of Irms and substitute the value of xc here. Therefore xc value we already know it, therefore 1 divided by or Vrms divided by xc. I am going to use this formula now. So Vrms is 110 volt divided by xc value, just we found it, that is 53.04. This is equal to 2.074 amps, and this is the value of the current in a circuit. Okay, we will see the next question. Obtain the resonant frequency of series LCR circuit. So resonant frequency they are asking here in a circuit with L value is 2 Henry and C value is 32 microfarad and R value is equal to 10 ohm. So they have given the LCR circuit. It is connected to an AC source. Here the value of L is given. L is equal to 2 Henry and C value is equal to 32 microfarad and R is equal to 10 ohm. What is the Q value of this circuit? What is the value of Q? So first obtain the resonant frequency. The resonant frequency is F naught is how much and Q is how much. So F naught we can calculate. Sometimes the resonant frequency is omega naught. You can calculate omega naught also, that is angular resonant frequency. But in some of the exam paper we observed that if they ask a resonant frequency, we can able to derive or get the answer for omega naught also, that is also considered to be correct. So omega naught or F naught, both the answers are considered in the final exam. So any one you can calculate or both also is possible. So we have F naught is equal to 1 divided by 2 pi root LC, or you can write, you just cross multiply it, you will get 2 pi F naught 2 pi f naught is nothing but, this value is nothing but omega naught, angular resonant frequency, and that is equal to 1 divided by root LC. So omega naught is equal to 1 divided by root LC. So I'm going to do it now for omega naught. So omega naught is equal to 1 divided by root LC, the value of EL and value of C we can substitute. The value of EL is 2 Henry and the value of C is equal to 32 microfarad. So if you calculate this, the value comes out to be 125. 125 unit of omega naught is radian per second. So once after getting value of omega naught, okay, we can calculate the value of Q. So Q is equal to, we have 1 divided by, there are three formula, among them one we can take. So omega naught CR we can take it. So that is equal to, substitute all the values. 1 divided by omega naught is 125. C value, this is 32 microfarad and R value is 10. So if you calculate all these values and the value comes out to be 25. So 25 is the value of Q factor of this circuit. Okay, next question. An 80 ohm resistance and 20 microfarad capacitor are connected in series with AC source. So there is a resistor and there is a capacitor, and both are connected to an AC source of 220 volt and 50 Hertz. So the value of Vrms is given and the value of frequency is given, and R value is 80 ohm and capacitor value is 20 microfarad. And they are asking here, calculate the potential difference across each of them. So what is the value of potential difference across a resistor and the value of potential difference across the capacitor VC? So to calculate VR and VC, we need to know what is the current value. So the first step to do this problem is, I'm going to write here, the first step you can calculate the value of Z. So Z, the formula of Z I'm going to write, that is equal to R square plus XL minus XC square. Since L is not there, only XC square we can write. And next, after getting Z value, the second step is calculate the value of Irms. So Irms is equal to Vrms divided by Z. Vrms is given and Z value also found, and you can calculate value of Irms. Once after getting Irms, same Irms is flowing into both the resistor as well as capacitor. So the value of VR can be found by using the current flowing through the resistor, that is Irms, multiplied by the value of resistor. And fourth step, we can able to calculate VC is equal to the current flowing through the capacitor multiplied by the reactance of capacitor, that is XC. But XC value we don't know. So this XC value we can calculate it first. So XC is equal to 1 divided by 2 pi f into c. So 1 divided by 2 pi value is 3.142, f value is 50 hertz, and c value is 20 microfarad. And if you calculate the value of xc, the value of xc is found to be 159.2 ohm is the value of xc. Once after getting the value of xc, we can start from first step. The first step is the value of z. So z is equal to square root of r square plus xc square. So substitute all the values. So r value is equal to, they have given the value of r, that is 80. So 80 square plus xc value, that is equal to 159.2, and this is the value of z. You can calculate the value of z, and z value comes out to be around 178.2 ohm, and this is the value of z. And once after getting the value of z, we can calculate the value of Irms, that is second step. So Irms is equal to Vrms divided by z. So Vrms value is 220 divided by z value square root of 80 square plus 159.2 square. So if you do this, the value comes out to be, that is the value of Irms is 1.23 amps. So this is the second step, and coming to the third and fourth step, that is VR and VC. So VR is equal to Irms into R. So the value of Irms is found, that is 1.23 into the value of R, that is 80. So if you calculate the value of VR, and the VR value is 98.4 volt. So this is the voltage drop or voltage across the resistor. And next, the voltage across the capacitor they are asking. So VC is equal to Irms into XC. So that is equal to 1.23 into 159. XC value is 159.2, and if you calculate this, it comes out to be 195.8 volt. So this is the value of voltage across the capacitor. So we'll see the next question. A resistance of 50 ohm, an inductor of 10 millihenry, and capacitor of 20 microfarad are connected in series to a 220 volt 50 hertz AC circuit. So we can draw the circuit: a resistance and an inductor and a capacitor. All these are connected in series with 220 volt 50 hertz AC supply. Calculate the value of current. Calculate the value of current and power factor in a circuit. So the current is Irms and the value of power factor, that is cos phi. They have given the value of R, that is equal to 50 ohm, and the value of inductance, that is 10 millihenry, and the value of capacitor, that is 20 microfarad, and the value of Vrms is given, and the value of frequency of AC is given. So Irms we need to calculate. So to calculate Irms, we have a formula of Irms, that is Vrms divided by Z. But we don't know the value of Z. So to calculate Irms, we have Vrms divided by Z, but we don't know the value of Z. We have to calculate the Z value first. So Z is equal to, so that is the first step to calculate the value of Z. But to calculate Z, we have a formula of Z, that is equal to square root of R square plus XL minus XC whole square. But we don't know what is XL and XC. So first we have to calculate XL and XC. So the first step in our problem is the first step we can use, that is calculate XL and XC. And the second step, calculate the value of Z. And third step, after getting the value of Z, we can calculate what is the value of Vrms, Irms. So we will get Irms value. And next, what they are asking in a problem, cos phi. So cos phi is the third step, fourth step. So that is cos phi. Use the value of cos phi, that is R divided by Z. So R value is given in the problem and Z value in the second step we already found. So these are the steps we will use. So the first step, XL and XC we can calculate. So we'll start from the beginning. So XL is equal to omega L. Omega value we don't know, that is why 2 pi F is the value of omega times L. So 2 into 3.142 into F value is given, that is 50 Hertz, and L value is also given 10 millihenry. Milli is 10 to the power minus 3. So if you calculate the value of XL, it comes out to be around 3.14 ohm. And next we can calculate the value of XC. XC is equal to 1 divided by omega C, and that is equal to 1 divided by 2 pi F into C, and this is equal to, substitute all the values, 2 into 3.142 into F value is 50 Hertz, and the value of C is given, that is 20 microfarad, that is 20 into 10 to the power minus 6. And if you calculate these values, and the value comes out to be 159.2 ohm. So we got XC value also. So this is the value of XL and this is the value of XC. So this is the first step got over, and coming to the second step. The second step is calculate the value of Z. So Z value. So Z is equal to square root of R square plus XL minus XC whole square. So substitute the value of R and the value of XL and XC. The value of R is given in a problem. So the value of R is 50 ohm. So 50 square plus XL value, that is 3.14, minus X is 159.2 whole square. So if you calculate this, and the Z value comes out to be 163.87 ohm, and this is the value of Z. So after getting Z value, IRMS value, that is the third step we can use. The third step I'm going to do here. So third step is the value of IRMS. So IRMS is equal to VRMS divided by Z. So VRMS value is 220 and Z value is 163.87. And if you calculate, the value of current is 1.34 amps, and this is the value of current. And next they are asking what is the power factor. So power factor of the circuit, that is cos phi. So that is the fourth step. Cos phi is equal to R divided by Z, and the value of R is 50 and Z value is 163.87, and the value, if you calculate, it comes out to be 0.3050, and this is the value of power factor. A capacitor and a resistor of 20 ohm are connected in series with 220 volt 50 Hertz AC supply. A capacitor and a resistor of 20 ohm are connected with an AC source of VRMS is 220 volt and frequency is 50 Hertz. Find the value of capacitance. What is the value of capacitance required to make the power factor is equal to 0.6? So this is what they have given it, and the C value they are asking. So only the information we have VRMS and F and cos phi. So we need to calculate value of C. So is there a relationship between C and cos phi? We need to check it. We have a formula of cos phi, that is R divided by Z. But we know the value of Z. The Z is equal to square root of R square plus XL minus XC square. Since L value is equal to 0, as there is no inductor, L is equal to 0, therefore XL is also 0. Only C exists, therefore XC exists. So R square plus XC square. So in the XC itself, we have the value of C, because we know that XC is equal to 1 divided by omega C. So this is the value of XC. In that XC itself, we have value of C. We can able to calculate C value. Okay, now we got cos phi is equal to R divided by square root of R square plus XC square. So we need to solve it here for XC. So first we will calculate the value of XC from this. So that is equal to, I'm going to cross multiply it. So X, that is R square plus XC square, is equal to R divided by cos phi. Okay, now we want to calculate XC first. Therefore, I'm taking square root on both sides, squaring on both sides, so that we will get R square divided by cos square phi. Okay, next XC square, or I'm going to write this side. This is XC square is equal to R square divided by cos square phi minus R square. So XC square, we can easily calculate it now. Or next step I'm going to write here XC is equal to 1 divided by 2 pi FC. I can do now itself, squared, that is equal to R square divided by cos square phi minus R square. So that is equal to, if you substitute R value, it's found to be 20 square divided by the value of cos phi is given. So cos phi is equal to 0.6. So 0.6 square minus 20 square. So if you do this, it comes out to be 711. 711.1. This is the value of 1 divided by 2 pi FC square, or this is just XC square. So this is the value of XC square we got. From this we can calculate the value of C square. So I'm going to continue this side. So that is equal to, or I'm going to do here itself, C square is equal to, if you solve for C square from the above equation, so C square is equal to 1 divided by 4 pi square F square into 711.1. So this is how we will get if you solve this equation. So then C is equal to, so I'm going to do this side. C is equal to substitute all the values. So 4 into 3.142 square. EF value is 50 square into 711.1. And the value of C after solving, you will get 1.19 into 10 to the power minus 4, or we can just write it as 119 micro, or into 10 to the power minus 6. So it is 119 microfarad, and this is the value of C. So this is what they are asking. So the value of C, we found it. Okay, the next question. A circuit contains an inductor of 10 millihenry, a capacitor of 1 microfarad and a resistance of 20 ohm are in series with 220 volt 50 Hz AC supply. Calculate the resonant frequency and current at resonance. So they have given here in a question, there is LCR circuit. It is connected to an AC source of RMS value is given. RMS value is 220 volt and F value is given, that is 50 Hertz. So L value is given, that is 10 millihenry, and C value is given, that is 1 microfarad, and R value is given, that is 20 ohm. Okay, now what is the value of resonant frequency and current at resonance? So we have a formula of resonant frequency, that is F naught is equal to 1 divided by 2 pi root LC. L value is given, C value is given, F naught value we can able to calculate easily. So 1 divided by 2 into 3.142, square root of L value is 10 millihenry, and C value is 1 microfarad, 1 into 10 to the power minus 6 farad. So if you calculate it, the value of F naught comes out to be 1592. Hertz, and this is the value of a resonant frequency. So at that resonant frequency, the current is maximum, and that current we need to calculate it. So at resonance, IRMS is equal to, you need to know at resonance XC and XL value becomes equal to, XC and XL both are equal. XC is equal to XL and IRMS is equal to VRMS divided by Z. So we can write VRMS divided by square root of R square plus XL minus XC square. Since XL is equal to XC, this value will vanish, and therefore we will get VRMS divided by R, and this is the value of VRMS, IRMS value. So if you substitute the value of VRMS, that is 220, and R value they have given in a problem, that is 20 ohm, and the value comes out to be 11 amps, and this is the value of current in a circuit. And next question, a 15 microfarad capacitor is connected to 220 volt 50 Hz AC supply. Find the capacitive reactance and the current in the circuit, both RMS and peak current. If the frequency is doubled, what happens to the capacitive reactance and current in the circuit? So they have given only the capacitor in a circuit of AC. and the value of AC is given, AC voltage, that is 220 volt, and the frequency is 50 Hertz, and the capacitor value is 15 microfarad, and they are asking what is the capacitive reactance and current, IRMS, as well as peak value of current, that is I naught. So now, so we have X is equal to 1 divided by 2 pi F into C. So that is equal to 1 divided by 2 into 3.142. F value is 50 and C value is given, that is 15 microfarad. So if you calculate this, the value comes out to be 212.31 ohm, and this is the value of Xe. And next, IRMS. So IRMS is equal to VRMS divided by Z, or VRMS divided by, since there is no value of XL and there is no value of R, so we can write only Xc. So VRMS is 220 divided by Xc value, we just found it, and the value is 1.03 amps. And next, I naught value we need to calculate. The I naught is equal to IRMS into root 2. So IRMS value is 1.03 into root 2, and this is equal to 1.45 amps. Okay, next they are asking in a question, what happens if the frequency is doubled? If the frequency is doubled, what happens to the capacitive reactance and the current? So we know that the frequency depends on the reactance, like this. So the frequency and the reactance, they are inversely proportional. So if the frequency is doubled, the capacitive reactance reduces to half. So Xc becomes half. And what about the current? The current is, and the relation between the current and capacitive reactance is like this. They are again inversely proportional. So if Xc is half and the current IRMS is doubled, so we can conclude that if the frequency is doubled, then Xc becomes half, and if frequency is doubled, the current also doubles, because IRMS and Xc are inversely proportional. If Xc is half, current doubles. So we can conclude when Xc, if frequency is doubled, the capacitive reactance reduces to half, and current, that is IRMS, that doubles. Okay, next question. A circuit contains 50 ohm resistor and 0.3 Henry of 2 ohm and a capacitor of 40 microfarad. All these are connected in series with 220 volt 50 Hertz AC supply. And here they have given the value of resistor connected 50 ohm, but inductor have a value of 0.3 Henry, but the inductor itself has its own resistance and that is 2 ohm. Therefore, the total value of resistance in a circuit that's found to be this 50 plus 2 ohm. Therefore, we can write the total value of resistance in a circuit. I'm going to write here that is R is equal to 50 plus 2. This is equal to 52 ohm. So this is the value of total resistance in a circuit. And I'm going to call this as R dash and this is R. R is 52 ohm. Now they are asking the value of inductive reactance, capacitive reactance. So inductive reactance XL and capacitive reactance XC and third one that is impedance. And next current in a circuit, power factor, and next one phase difference between voltage and current. So first we will calculate what is the value of XL. So XL is equal to omega into L, that is 2 pi f into L. So this value is 2 pi, the value of f is 50 and the value of L is given, that is 0.3. And if you calculate the value of XL comes out to be 94.2 ohm, and this is the value of XL. Next XC value. So XC is equal to 1 divided by 2 pi f into C. This is 1 divided by 2 pi, f value is 50 and C value is given 40. 40 into 10 to the power minus 6. And the value of XC comes out to be 79.61 ohm. And next they are asking what is the value of Z. The value of Z is equal to square root of R square plus XL minus XC whole square. So this is equal to the R value, which is equal to that is 52 square, and the value of XL is 94.2 minus XC is 79.61 whole square, and the value of Z comes out to be 54 ohm. So this is the value of Z. And next they are asking what is the RMS value of current. Is equal to V RMS divided by Z, that is equal to 220 divided by Z value is 54, and the value of IRMS is 4.07 amps. And next they are asking what is the value of power factor. So power factor cos phi is equal to R divided by Z. So R value is 52 and Z value is 54 and this value is 0.96 and this is the value of power factor. And next they are asking what is the value of phase difference. So now we just got cos phi is equal to 0.96. Then if you calculate phi value, phi is equal to cos inverse 0.96 and this is equal to 15 degree 55 minutes and this is the value of phi, phase difference between voltage and current. Okay, next question. A series LCR circuit comprising of an inductor of inductance 3 Henry and a resistor of resistance 7.4 ohm and a capacitor of capacitance 27 microfarad. When connected to an AC source, the circuit resonates at a particular frequency. Calculate the angular resonant frequency and quality factor of the resonant circuit. So they have given a circuit consisting of L, C and R. To an AC source, and the value of L is given, the L value is equal to 3 Henry and the value of resistance that is equal to 7.4 ohm and they have given the value of capacitance that is equal to 27 microfarad. So the circuit resonates at a particular frequency, we don't know that, and we need to calculate what is the value of angular resonant frequency. So what is the value of angular resonant frequency and quality factor Q. Okay, now we can calculate the value of omega naught by using angular resonant frequency. Omega naught is equal to 1 divided by square root of LC. So we'll substitute both the values of L and C. L value is 3 Henry and C value is equal to 27 into 10 to the power minus 6. So if you calculate it, the value of omega naught found to be 111.1 radian per second, and this is the value of omega naught, that is the angular resonant frequency. Next they are asking what is the value of Q, that is Q factor. So Q factor formula I can use Q is equal to omega naught L divided by R. So there are 3 or 4 formula are there for Q, any one you can use. So omega naught L divided by R, omega naught value we found 111.1 into L value that is equal to 3 Henry divided by R value is 7.4. So if you calculate it, the value comes out to be 45.01 and this is the value of Q. We'll see the next question. A sinusoidal voltage of peak value 283 volt. So they have given here the peak value of AC that is 283 volt, and a frequency 50 Hertz is applied to a series LCR circuit in which R value, L value and C value is given. So let us draw the diagram first. So we have LCR circuit. So this is a LCR circuit connected to an AC source, and they have given the peak value. Here they have given V0 value that is equal to 283 283 volt, and frequency is given, the frequency value is equal to 50 Hertz, and the value of L, C and R. L value they have given it here 25.48 Henry, and C value that is equal to 786 microfarad, and the value of R is also given, that is equal to 3 ohm. Okay, now find the value of, so what is the value of impedance? So what is the value of impedance? First one, and second one they are asking phase difference between voltage and current, and third one they are asking the power factor. Okay, first we need to calculate the value of Z, but formula of Z is square root of R square plus XL minus XC whole square. Here in this formula we don't know what is XL and what is XC, so first we will calculate what is XL and what is XC. So we are using, these are the steps. I'm going to write the steps here. The first step is calculate XL and XC. After calculating this, the second step is calculate the value of Z. So what is the value of Z we can calculate, and later they are asking here what is the phase difference. So phase difference between voltage and current, that can be calculated by using the formula, that is tan phi. Tan phi is equal to XL minus XC divided by R. And later after finding this we can easily calculate what is the value of phi. So phi value we will get it by above relation, and later the fifth step they are asking here calculate the power factor. So take cos phi. So this is the value of power factor. So now we will use the step by step. The first step, XL and XC. So XL is equal to 2 pi f into L. So that is equal to 2 into 3.142 into f value they have given, that is equal to 50 Hertz. 50 into the value of L is given, the L value is equal to 25.48. 25.48. If you multiply all these values, the value of XL comes out to be 8 ohm. Now we will calculate the value of XC. XC is equal to 1 divided by 2 pi f into C. This is equal to 1 divided by 2 into 3.142 into f value is given, that is equal to 50, and C value is given, that is equal to 786. 786 into 10 to the power minus 6, and if you calculate it, the value of XC comes out to be 4. And next we will calculate Z. So Z is equal to Z is equal to square root of R square plus XL minus XC whole square, that is equal to square root of R value is equal to, they have given it the value of R, that is 25, that is 3 ohm, and C value is also here and L value is also here, so we will use those values. So R value, so R is equal to 3, and XL and XC we just found it, the value of XL and XC we can substitute those values. So XL is equal to 8 and XC is equal to 4. Therefore we will get 8 minus 4 whole square, and if you calculate it, the value is 3 square plus 4 square, that is equal to under root 3 square plus 4 square is 5 ohm. So this is the value of Z. So after getting the value of Z, we can calculate what is tan phi. So that's what they are asking in a problem. So tan phi is equal to XL minus XC divided by R. So that is equal to XL value is 8 and XC value is 4 and R value is 3. So if you calculate it, the value is 4 divided by 3, that is 1.33. So this is the value of tan phi. Then phi is equal to tan inverse 1.33, and this value is 1.333, one more 3. So if you find this value from the Clark's table, the value comes out to be 53 degrees 6 minutes. So after calculating this, we can able to calculate, so what is the value of power factor, that is cos phi. So power factor cos phi is equal to R divided by Z, and R value, that is 3 divided by 5, this is equal to 0.6. So this is the value of power factor, that is 0.6. So this is what they are asking in a problem. So first we calculated Z value, and next phi value, and later cos phi. So this is a power factor, and this is the phase difference between voltage and current. So this is A and this is B and this is C. Okay, and the next problem we will solve. A primary coil of an ideal step-up transformer has 100 turns and turn ratio is also 100. The input voltage and power are 220 volt and 1100 watt respectively. Calculate the number of turns in the secondary and the current in the primary, and third one, that is the current in the secondary and voltage across the secondary, and the next one power in the secondary. So they have given here step up transformer. That means the number of turns in the primary should be less than the number of turns in the secondary. So this is the input side and this is the output. So they have given all these values. NP value they have given, number of turns in the primary, that is at the input side, 100, and the power at the input, that is power at the primary, that is 1100 watt, and voltage in the input side, that is equal to 220 volt, and T value is also given, that is 100. And these are the values they are asking: NS, IP, IS, VS and PS. So S means output side or secondary side, secondary of the transformer. P means primary. So for calculating all these values, I'm using, these are the two formula, that is turn ratio formula and power. So we will solve the first one. So that is number of turns at the secondary or number of turns at the output side. So that can be found by using the first part of the formula, that is T is equal to Ns divided by Np. So here Ns is equal to T times Np. So T value is given in a problem, that is 100, and they have given the value of Np also, that is also 100. So that is equal to 10,000. So 10,000 turns are present at the secondary side. So there are 10,000 turns at the secondary of the transformer. And next they are asking what is the current at the input side, the current at the primary side. So that can be found by using a power. Second formula I'm using for that. So the current at the input side. So you can write like this. So PP, the current at the primary, is equal to voltage and current at the primary. So then IP is equal to, I'm using the second formula. So IP, current at the primary. Current at the primary is equal to power at the primary divided by VP. So if you solve this, PP value they have given, PP is equal to 1100 divided by, they have given the value of Vp, that is 220. So if you calculate this value comes out to be 5 amps. So 5 amps is the current at the input side, of the transformer. And the next one they are asking what is the current at the secondary. So what is the value of current at the secondary of the transformer? So that can be calculated by using PS is equal to VSIS. So third one, IS is equal to PS divided by VS. So that is equal to PS value. The PS value they have given it here. So the value of PP they have given, but since they have given here in the question itself, it is an ideal transformer. So for ideal transformer, the power at the input is equal to power at the output, that is secondary. You remember this. So this is actually the value of PS, because PP is equal to PS, power at the input is equal to power at the output. So both values are same. So I'm using that. So PS is equal to 1000 100 divided by Vs. So the value of Vs, that is voltage across the secondary, that is 22000. So that is equal to 0.05 amps. Then how you got the value of Vs? The value of Vs you will get by using this part of the question. So T is equal to Vs divided by Vp. T is equal to Vs divided by Vp. Then Vs is equal to Vp into T. Then Vp is equal to Vp is 220 and the value of T is given in a problem, that is 100. So if you multiply this, you will get 22000 and this is the value of Vs. So this is how we found it. Okay, next they are asking, so from this one only we got the value of Vs, and the next they are asking the what is the value of Vs and later Ps. So Vs is already found just now. So this is what the value of Vs. So this is the fourth one. And next we will calculate the fifth one. So fifth one they are asking what is Ps. So what is the value of power at the output side? So power at the output side we can calculate it. Ps is equal to Vs Is. So that is equal to since we have a note that the power for ideal transformer power at the input is equal to power at the output. That means power at the primary is equal to power at the secondary. So they have given primary power is equal to 1000. I will see that the power they have given it, so 1100. So both the values are same for ideal, 1100. So the value of power output is equal to 1100 watt.